In this video, I want to take a few minutes to talk about how we can improve our local development workflow. So currently, if we're working on the application and changing our JavaScript files, we have to manually switch over to the terminal and rerun the build script in order to actually see our changes reflected. That slows us down. It's super annoying to have to come over here and rerun the script every single time we make a change. So we're going to go ahead and talk about how we can improve this workflow so we never have to go into the terminal as we're developing our app. We work in either Visual Studio Code or the browser, the terminal sits in the background, and we never need to touch it. This is very similar to what we did with Babel. We configured Babel to watch our files for changes and rerun Babel when any of the files changed. That's exactly what we're going to be doing with Webpack. Now, there are two solutions to get this done. There is the 5-second solution and the 5-minute solution. One is easier, but a little simpler. The other is a bit more complex to set up, but comes with its own set of advantages. In this video, we're going to talk about both. Let's put 5 seconds on the clock and dive into the 5-second solution. All this requires us to do is add a single flag onto the Webpack command. We add on --, watch, and we're done. So what this is going to do is that it is going to run Webpack when we run the command, but then Webpack is going to stay up and running. It is going to watch any of the files that make up the bundle for changes. So in this case, it's going to watch index.js, but it's also going to watch anything that index.js imports. So that would be Scream and utilities. So the end result is that it is going to watch all of our source files for changes. When any of them change, it is going to generate a new bundle. That's going to cause Live Server to refresh the browser, and we should be able to get everything up and running. We should have a much nicer workflow. I'm going to save package.json, and over in the terminal, we're going to rerun our script. So npm run build. It is going to generate the bundle right away initially, but you'll notice we're not brought back to the command line. The Webpack command is still running. It's watching for changes. Let's go ahead and actually make a change. I'm going to change in utilities.js the value used for the name. Currently, it's Andrew. I'm going to switch this over to pretty much anything else. I'll go ahead and use Mike. Now, Webpack is generating a new bundle. Live Server picks up on that new bundle, and the end result is Mike showing up in the browser. So that is the 5-second solution. It gets the job done, and it allows us a nicer workflow. No longer do we have to switch into the terminal and rerun any scripts to be able to view our application changes, even when we're using more advanced complex tooling like Babel and Webpack. Now I want to move on to the 5-minute solution. It's going to require a bit more time to set up, but it comes with its own set of advantages. So let's go ahead and talk about the Webpack Dev Server. The Webpack Dev Server essentially does everything we're already doing, but in one tool. So instead of needing to run Webpack with the watch flag and Live Server in separate tabs, Webpack Dev Server gives us a single process we can use to do both. We're going to kick things off by installing this tool. Then we're going to add about 5 or 6 lines of code to this file, and then we'll be all done. So let's go ahead and start by moving into the terminal and running an npm install command. I'm going to use Control-C to shut down Live Server. Then we're going to use npm install. We're going to be installing the Webpack Dev Server, and we're going to grab the most recent version, 3.1.3. Now, once this finishes installing, we're going to have to make a few changes to the Webpack config file to get the dev server to work. There are 2 main things we have to provide, and they both relate to us telling the dev server where it can find the content it's supposed to serve up, much like we tell Live Server to serve up the content in the public directory. So let's go ahead and knock this out. It's just going to require a couple of additional lines. We're going to add a new root property onto our config object, so alongside of entry, output, and module. This one is called dev _S server, and this gets set equal to an object. On here, there are 2 paths that we're going to provide in order to correctly configure the dev server. The first of those 2 properties is content base. Content base's value needs to be an absolute path that lets the dev server know where the folder you're trying to serve up lives. So with Live Server, we told it was the public directory. With the dev server, it's still going to be that public directory. The only difference is in how we specify it. We have to provide an absolute path right here, and that's very similar to what we did up above for path. We have to combine __dir name with the public directory. So right here, path.resolve. We are going to pass those two arguments in. The first is __dir name, which we talked about earlier in this section. And the second one is just, in quotes, public. So this tells the dev server to serve up that public folder. Now, the next property we're going to provide is public path. The value for public path is a string, and this is where we tell the dev server where, relative to the public folder, Webpack puts our assets. In this case, it's in the scripts folder. Now, it might seem a bit redundant to need to provide this again since we're already providing it up above, but don't worry, we'll talk about why this is in just a few moments when we start exploring some of the advantages of the dev server. So right here, as the value for public path, it's going to be /scripts/. That gets us from the public folder into the scripts directory, which is where Webpack usually saves the assets. All right, with that in place, the dev server is all configured. The only other thing we have to do before we can actually run it is change one of our scripts to use the correct command. Over in package.json, let's go ahead and knock this out. We're going to end up redoing the scripts over and over again as we learn new tools and techniques. So I'm going to start by deleting everything we have in the scripts object, and we're going to create just one. The script name itself is going to be dev-server, and the value is going to be us just running webpack-dev-server. There's no need to add any arguments onto the end, as all of those are provided in the Webpack configuration. Now we can go ahead and save package.json, and we can actually run the dev server for the very first time. Over inside of the terminal, I already have live server shut down. I can clear this terminal tab, and in the next terminal tab, I still have Webpack running. We don't need that running anymore either, so I can shut that down and use clear to clear the output. Now, neither tab is doing anything. We just need one tab to run the dev server. That is npm run dev-server. And when we do this, it's going to do a whole bunch of things. The first thing we're going to see in the output is some information about the server itself. So if I scroll up real quick, it outputted that we need to be looking at port 8080 to find the app, which is exactly what we're currently using already. That is the default port. Down below, we're getting some output that looks similar to what we got when we just ran Webpack. It is indeed working on creating that bundle file. And then at the very bottom, we are getting the warning we had before, which we will actually address in the very next video. Now, in the background, we have our browser. We can actually refresh things to start using the dev server. I'm going to give things a refresh, and what do we get? We get the same output we had before, although this time we're also seeing that warning, which we will address in the next video, so we can ignore for now. So this is the first half of things. Clearly, the dev server is indeed creating a web server, allowing us to view the application, but does it still recompile things on the fly? We can test this by making a change to one of our files that make up the application source. I'm going to change index.js. Instead of adding 32 and 1, I'm going to add 32 and 3 for a total of 35. If I go ahead and save things without switching into the terminal at all, we can see in the background it's letting us know that it is recompiling our application. Then things refresh, and what do we get? We get the latest results, going from 33 to 35. Along the way, you might also get some output talking about how your browser can't establish a connection to the correct location. This typically comes up every so often when using the dev server, but don't worry, the browser is going to automatically reconnect itself, so you can ignore this warning when it comes up. If I was to make another change to the application, switching 3 to 4, it would still indeed work. In the background, I am getting that message saying it's going through the process of recompiling things. Then I get 36 showing up. So you don't have to worry about those connection issues. The browser takes care of that automatically. The dev server lets us do everything with just a single tool, and it also comes with optimizations to make things faster. One of them is the fact that it doesn't actually ever write a file to the scripts directory. This file right here is a leftover from the last time we ran Webpack. If I were to delete it and refresh the browser, we can see that things are still working, even though in Visual Studio Code, the file it should be looking for doesn't exist. So that's why we needed to provide the public path over here. This lets the dev server know where it should serve up those virtual files that don't actually exist in the file system. All of this allowing the dev server to stay as fast and as lean as possible. Now, clearly, this is not well suited if we actually want to take the public folder and put it on a web server like we did previously, because we need all of the assets. Don't worry, We're going to come up with a good solution for that, very similar to what we had before. The biggest difference is that we're going to optimize for either development, what we're doing now, or production, when we're ready to actually deploy our application. That topic of development versus production is coming up in the very next video, which I'm excited to get to. So let's go ahead and jump right in.